So today we're going to talk about analyzing graphs of polynomial functions, and it's really a lot of what we've been working with over the past week and a half or so. And in fact, on some of our review problems that we do at the beginning of the class, we have done some of the same things here. So when we look at this first one, it says analyze the graph of the polynomial function. And the first thing that it asks us is, what is the degree of this function? And if we look at our exponents here, there's an exponent of 2 and there's an exponent of 1, which means that the degree of our polynomial is 3. And how many turning points can we have if we have our degree of our polynomial is 3? Same number. Now, for the end behavior, it's going to be nice because eventually we're going to have to draw our picture farther down on the page, but let's type it into our calculator now and look at the screen. So if we go to y equals and negative x squared times x minus 3. We don't even have to put it in standard form. But what we can see is that our end behavior is up, down. So now what we have to do is we have to find the x-intercepts of the graph. And remember that x-intercepts aren't the only name for... X-intercepts aren't an exclusive name. Oftentimes I call them roots. They can also be called zeros. And it just depends on the paper, the words that we've used in Algebra 2. Trying to familiarize ourselves with all of the different vocabulary associated with this. But what we do with this is we say negative x squared equals 0. And x minus 3 equals 0. And we're going to have to do a little bit more here because we're going to have to state the multiplicity and how it behaves at the x-axis. But let's start there. And actually, this part here, that's not the part that gives people trouble. We add 3 to both sides, we get x equals 3. That doesn't seem to cause people trouble. But you look over here at this negative x squared, and maybe or maybe not it causes you trouble. When we solve this, we would have to divide both sides by negative 1. And so now we have x squared equals 0. And then we can take the square root of both sides. So x equals 0. Now if you're really thinking about this, we just drew the graph here. Can you see those roots on the calculator? 0, 1, 2, 3. Nothing wrong with using your calculator to help you answer the questions. Now, what we also want to know is their multiplicity. Well, what is the multiplicity at 0? Remember, it's the exponent on that. And what is the multiplicity at 3? So the multiplicity is 2 at 0, m for multiplicity. Multiplicity at 3 is 1. Do we cross or do we touch when the multiplicity is an odd number? We cross. So back here at our root of 0 with the multiplicity of 2, 2 is an even number, so do we cross or do we touch? We're going to touch. Next, it says determine the y-intercept of the polynomial without graphing it in your calculator. In order to find the y-intercept without graphing, what we have to do is we have to let of reasons why we don't necessarily need to multiply to put it in standard form, and it's not that difficult to do in this particular case. But if we go back into this function, we're going to put 0 back in here at this x, as well as this x. In fact, I'm going to be a little bit more technical, just because we have the time and the space. And our function is negative x squared times x minus 3. So we're going to take this value of 0, and we're going to put it back into our function here. And we're going to put it back into our function here. So I'm kind of going the long way here, but I just want to show the math behind it. So we get negative 0 squared times 0 minus 3. Oh, wrong colors there. But ultimately what we end up with is we end up with negative 0, because 0 squared is 0. And then 0 minus 3 is negative 3. What is negative 0 times negative 3? Is 0. And we didn't, after we found out that this was 0, we didn't even really need to write that negative. So our y-intercept of the graph is 0, 0. And again, we already drew the picture in. Let's check that. And we could check it in the picture, and we could check it in the table. I don't want to omit that, and I've got some funny stuff up here, but here's 0, 0. There's our y-intercept. We already found our x-intercepts in that earlier part. So, when we go to draw the picture now, we already have the picture to look at. We're going to draw a sketch. So we want to make sure to get our roots and our multiplicity here. Look at the picture one more time. Maybe I'll just scan that in real quick there. And roughly. So the last part here on our graph is, what's the domain of this function? There's only really one answer. All right. The range. Do we have a high point or a low point on the graph? And it has to be the highest point or the lowest point on the graph. And we don't, so what's the range? Still all real. So hopefully today we can finally pull that together, because if there's going to be something that we miss on the test, conceivably I think it's the domain and the range. The rest of it, I hope we won't miss. So basically the second problem is very, very similar. I wish that I would have changed one thing, but we're kind of living and learning as we get back to writing some of our own notes, first of all, which I have no issue with. But the first time we use them, we have little mistakes. And I don't think it's a mistake. I just don't think that this problem is dramatically different from the first. What's the degree of our polynomial? It's 3. Remember, the exponent on this is a 1. 1 plus 2 is 3. So if our degree is 3, how many turning points do we have? 1 less. Somebody says.
On the front, you said the maximum number.
Made a mistake on the front. So let's go back and fix that mistake that I wish somebody would have corrected me on a long time ago. The degree of the polynomial was 3. The maximum number of turning points is 1 less than the degree, so it is 2. Sorry about that. And then we'll flip back here to our second problem. So good, we at least got that corrected, as I will post these notes online soon enough. So we need to have right answers on the paper, or on the video. So now that we see the maximum number of turning points is really 2, let's look at our end behavior. And we'll do that by typing this function into the calculator. So we went to y equals, and it's 3x minus 1 times x plus 2 squared. Particularly looking at this picture from the standpoint that we want to see the end behavior. And what is our end behavior? Down, up. Down, up. So now we have to find the x-intercepts of the graph. And the x-intercepts are coming from our parentheses up there in the original problem. We're going to take 3x minus 1 and set it equal to 0. We're going to take x plus 2 and set it equal to 0. We don't need the exponent. The exponent is determining the multiplicity. So we'll use that in this particular section of the problem. But right now, let's come up with the x-intercepts, or the roots, or the zeros of the function. And we might have to do a little bit of work over here. We add 1 to both sides. And then we divide both sides by 3. So we end up with x equals 1/3. On our other root, you may be able to look at that one. We're going to subtract 2 from both sides, and we get x equals -2. What's our multiplicity on our root of 1/3? Do we cross or do we touch? When our multiplicity is odd, we cross. For those of you who were absent earlier this week, that's what that was our highlight on our earlier class this week. Over here, our root is x equals -2. That came from the parentheses that has x plus 2 in it. What's our multiplicity? It's also 2, coming from that exponent. And when our multiplicity is even, do we cross or do we touch the x-axis? Even means that we touch. And if you forget that, eventually here in a couple minutes we're going to be finding or drawing the picture. But if you look here, here's -2. See how it touches? It stays below. That part of the graph stays below the x-axis. And over here on our other root, it crosses. In our graph, we've got parts that are above the x-axis and parts that are below the x-axis. But what we want to do next is we want to figure out the y-intercept, and we are then going to check it on our graph. We want to do it by hand. And the reminder, once again, is to figure out what the y-intercept is, we have to let x equals 0 in our function. So we go back to our problem here, and it's going to be 3 times 0 minus 1 times, in our other parentheses, 0 plus 2 squared. We're replacing the x in our function with 0. So 3 times 0 is 0 minus 1. Over here, 0 plus 2 is 2 squared. 0 minus 1 is negative 1. And 2 squared is 4. So this time our y-intercept is negative 4. If we write it as an ordered pair, it's 0, negative 4. And again, let's use the graph to help us. Well, does that make sense? 1, 2, 3, 4, it looks right. You can't see it very well on here, but if we go back to our table, 0, negative 4. I know, I'll fix my table here so it looks more like yours. 0, negative 4, right there at the top of the screen. So now, what we're going to do is we're going to draw that picture. And we already have it on our screen. And as I said before, it's similar to the last problem. But we got an intercept here and roughly there. And we want to make sure that we get something like that. My picture is a little bit ugly, but hopefully yours is better than mine. Just want to point out that here is a turning point and here is a turning point. Because we talk about maximum number of turning points, but we haven't really looked at them on the graph lately. What's the domain of this function? All right. And then we're going to look at the range. Do we have a complete high point, no other high points in the graph, or a complete low point, no other low points in the graph? And because we don't, our range is also our range.